For this afternoon, you will get to learn all about chemical kinetics, chemical equilibrium to be specific, and the incorporation of the principle Chatelier's. So, how do we distinguish a chemical reaction attaining an equilibrium state? Now, in a chemical reaction, once the forward reaction equals to that of the backward reaction, ibig sabihin, equilibrium is already reached. So in that case, chemical reaction is at equilibrium, meaning isa siyang reversible. Okay? So reversible type siya na reaction. Okay? So say for example, on the given general chemical reaction shown in the slide, A plus B is equivalent to C and D. Or vice versa, C and D is also equivalent to A plus B. Now, in a chemical reaction, this part, okay, yung A plus B dito, okay, before the arrow to the right, ito yung reactants. Take note ha. Ito yung reactants in a chemical reaction. And these substances formed upon the forward reaction ng reactants is the products. Okay? Now, so again, this is an example of chemical reaction at equilibrium state. But although a system is at equilibrium, it can still be probably disturbed. So, pwede pa rin siyang ma-disturb. Pwedeng ma-disturb yung ma-stress, yung state ng chemical reaction at equilibrium. But good thing, pag yung equilibrium system, once ma-subject siya sa stress, once ma-disturb siya, good thing, meron siyang own mechanism. Meron siyang own way to relieve that stress in order to re-achieve equilibrium. Okay? Now, that principle is actually the Chatelier's Principle. Okay? Sabi ng Chatelier's Principle, when an equilibrium is subjected to stress, that system will shift. It will try to shift. It will try to produce its mechanism to try to relieve that stress in order to re-achieve again the equilibrium. So, yan yung Chatelier's Principle. So, ano yung mga example? Example ng mga stress that we could put on a system at equilibrium. So, there are different stress, disturbances na pwede nating i-place on a system at equilibrium, pero yun na nga, with Chatelier's, kaya niya pa rin ma-relieve yung stress. Okay? Kaya niyang mag-shift para ma-relieve yung stress, para ma-restore back yung equilibrium state niya. So, ito yung mga example ng stress that we could put on a system. Okay? So, example, the concentration, temperature, pressure, catalyst, and the order of reaction. So, let's have the first one, concentration. Okay, how can concentration affect the chemical equilibrium? Okay? And how a chemical reaction at equilibrium state relieve that particular stress being placed. And that is any form of concentration. Now, kung ang ating gagamitin na stress, okay, to disturb a chemical reaction at equilibrium is concentration, we can modify. We can modify the concentration of any substances or compounds. So, pwedeng i-increase natin yung concentration ng reactant side, or pwede din naman natin i-increase doon sa product side, or pwede din naman sa i-decrease natin yung concentration sa reactant, or pwede naman din i-decrease yung concentration sa product side. So, ganun yung example ng stress under concentration. Kaya nating i-decrease or increase, kumbaga. So, say for example, in this given general reaction at equilibrium. So this is a chemical equilibrium state na reaction. Say for example, yung in-apply na stress is concentration. Okay? So A plus B equals C and D. Then we apply the stress via increasing, for instance, the concentration of the reactant A. Example lang ha. Example, naglagay tayo ng stress ngayon, dinisturbo natin yung reaction at chemical equilibrium by increasing the concentration ng reactant A. So, in-increase natin. Now, sabi ni Chatelier's, yung gagawin ng reaction, chemical reaction at equilibrium state, magkakaroon siya ng shifting. Mag-shift siya. Okay. Now, since dito tayo nag-apply ng stress sa reactant side, ang gagawin ngayon ng equilibrium to restore back its state na equilibrium siya, forward reaction. So, itong forward reaction, kakapalan ko ha, itong forward reaction, it will speeds up. Okay? So, erase ko muna to. Ayan. Again, para ma-restore back yung equilibrium upon increasing the concentration ng reactant A, forward reaction speeds up. Okay, so it will speed up. Now, para ma-understand, bakit kailangan mag-speed up? Bakit ganun yung pag-shift? Bakit hindi pa backward na reaction? Bakit yung forward reaction? Okay, to easily understand this, let's try to use this concept. Try natin i-use yung concept of a U-tube. Okay, example, meron tayong U na tube. Okay. U-tube. Okay. Na filled with equal amounts. Example, dito yung reactant side. Dito naman yung dito sa product to ha, product side. Okay? So say for example, dito yung A plus B. Kasi reactant. Then dito yung C plus D. So parang ganun. Sabi, pag chemical equilibrium, equal. Tama? Equal. So ibang kulay na lang ha. Ayan. Equal. Kasi chemical equilibrium. Sabi natin, nilagyan natin ng stress. Nag-add tayo ng stress. In-increase daw natin yung concentration ng reactant A. Asan ba si reactant A? Andito siya sa side na to ng U-tube. So pag in-increase natin, okay, say for example, increase natin. So mag-i-increase ngayon, yung concentration, hindi na ngayon pantay. Tama yung concentration sa reactant side tsaka sa product side. Now, sabi ni Chatelier'S Principle, para ma-relieve yung stress, para ma-restore back yung chemical equilibrium state, mag-shift ngayon. Okay, mag-shift ngayon yung system. Okay, so saan siya mag-shift? Saan ba yung kulang? Okay, syempre doon sa product side. That is why forward reaction will speed up. Okay? Para ma-restore back yung chemical equilibrium. So this time, pantay na sila ulit. Chemical equilibrium ulit. Okay? So yan yung characteristics ng system at chemical equilibrium. Kahit may mga stress, disturbances, okay, na in-apply sa system, kaya nilang mag-adjust, kumbaga, kaya nilang i-relieve yung stress na yun. Okay, so sana all, di ba? So, let's have the second factor affecting the chemical equilibrium. So, another stress. Okay, let's have another stress. Gabi, no? Stress na lang natin, pinag-uusapan natin dito. Okay, so let's have the second one, temperature. Okay, so temperature, to see how this factor affect the system at equilibrium, we have to first determine whether ang reaction ba at chemical equilibrium is an exothermic type of reaction or endothermic type of reaction. So, kailangan muna natin i-identify. Okay? Kasi may involvement na kayo ng temperature. Okay? So, again, para malaman natin na kung ang temperature ba nakaka-apekto sa system at equilibrium, we have to determine first. Kailangan mo munang i-determine kung exothermic reaction ba yan or endothermic reaction? Okay? So, pag exothermic, di ba, in general, exothermic, yung system, yung chemical reaction, releases heats na noon, Miami heats. Okay, so, pag ang exothermic type siya ng reaction, okay, ibig sabihin yung system nag-release ng heat. Okay, so nag-release, saan ngayon yung heat? Sa reactant ba or sa product side? Nag-release ng heat. So, ibig sabihin, yung heat nasa product side. So, ito yung, sulat ko ha, ito yung exothermic. Okay, ito yung exothermic reaction. Ibig sabihin, ang system nag-release ng heat. Okay, paano naman yung endo? Okay, pag sinabing endothermic naman, ibig sabihin, nag-absorb. Ang system ngayon, upon undergoing chemical reaction, nag-absorb ngayon ng heat yung system. Okay? So, pag absorb, ibig sabihin, ang heat ngayon nasa nasa reactant side. Okay? So, ito naman yung endothermic reaction. Okay? So, endothermic reaction, ibig sabihin nag-absorb ng heat from the surrounding, yung reaction. Okay? Now, in this case, pag ang isang reaction endo or exothermic, di ba may involvement ngayon. Ang pangit ng kulay green, no? Okay. May involvement ngayon ng heat. Okay. In this case, yung heat po, you treat that as another substance in the reaction. Okay? So, you treat that as if part naman talaga siya ng reaction, di ba? So, pag sinabing exothermic reaction, part yung heat sa product. Pag endothermic reaction, part yung heat sa reactant. So, again ha, for exothermic reaction, which releases heat energy, the heat energy here, okay, yung heat energy here, will be treated as one of the products of the reaction. Whereas, in endothermic, okay, which absorbs heat energy, in this case, the heat energy naman dito will be part of the reactant side. So, ngayon, let's determine how. How can this temperature affect a system at equilibrium? Okay? Now, so ganito po yun. Whenever, say for example, you increase the temperature. Okay? So, whenever increase natin yung temperature, example sa exothermic, increase natin yung temperature. Asan ba yung heat? Diba nasa product? So, increase natin. Sa endothermic, increase daw natin yung heat. Okay? So, increase daw natin yung temperature. Okay? So, that is an example of stress. You increase the temperature. So, when temperature is increased, syempre, there will be more energy, there will be more heat energy. Okay? Now, para ma-restore yung equilibrium, para mabalik yung equilibrium, things will shift on other sides para ma-use up yung some of the excess heat and therefore relieve the stress. Ibig sabihin, sa exothermic, since ang daming excess heat dito sa product side, ano yung mangyayari ngayon para ma-relieve yung stress? Saan papunta yung shift? Okay? Papunta yung shift sa backward direction. So, i-highlight natin yung backward direction. Ito yung kumbaga a mechanism ng system para ma-relieve back ma-restore back yung equilibrium. So, backward direction will speed up. Okay? Now, pag endothermic naman, tingnan, asan ba yung heat? Diba? May mga excess heat sa reactant side. Now, para again ma-restore back yung equilibrium, mag-shift yung system pa forward. So, this time, forward direction will speed up. Okay? So, yan yung way ng system para ma-restore yung stress. I mean, ma-restore yung stress, ma-restore yung equilibrium due to stress. Okay? So, ito yung sa temperature. Okay? So, okay na tayo sa temperature. Let's have pressure naman. So, pressure. Grabe na. Grabe yung mga inaaral natin. Stress, tapos pressure. Okay? So, ito naman ha, related lang to sa chemical kinetics, sa chemical reaction. Okay? So, pressure is another factor. Another factor that can affect a system at equilibrium. Usually, pag sinabing pressure, applicable siya to gaseous. Okay? Applicable siya sa gaseous molecules kasi 'di ba among the three states of matter, solid, liquid, gas, much more sobrang compressible yung gaseous molecules, yung gas molecules. Okay? So, very applicable yung pressure na stress sa mga gaseous molecules. So, say for example, yung mga carbonated drinks para mas maintindihan. 'Di ba? So, maghatag ko example. Carbonated drinks. So, may example sa carbonated drinks. Soda, kanang mga soda drinks, kanang Sprite, Coke, Royal, Mountain Dew, okay, tanan na nga brand sa carbonated drinks. So, kana sila mo na silang mga soda drinks. Okay? So, basically, the gas present in soda drinks is the carbon dioxide. Okay? Yung gas, yung gas present sa mga soda drinks, that is carbon dioxide. And at the same time, yung gas na yan yung responsible for the palatability of soda drinks. Kaya sobra ka lami. Okay, ang soda drinks, di ba? Labi na kung bugno kaayo. That is because of the presence of the gas carbon dioxide. Bantog kabantay mo kung di ba wala pa nimo na open. Pero the moment nga i-open na nimo, okay, ang first inom pack lami kayo. Pero kung i-stay na nimo madugayan ang Coke na nakaabri, okay? Ano yung mangyayari? Okay? Pag next nimo nga inom, nga gikan siya nagstay for pila ka mga minutes, pila ka hours, dili na kayo siya nga nakalami. Kaya nga naman, ang carbon dioxide as a gas, nag-escape naman siya, nag-escape na siya, okay, from the surrounding. Okay? So, nag-escape na siya from that bottle. So, wala na kayo palatability ngayon na characteristics yung soda drink na iniinom mo. Okay? So, again, si carbon dioxide din yung reason na bantog lami ang soda drinks. Okay. So, balik tayo sa pressure. Okay? Now, imagine you have a bottle. Ngayon, may hawak ka, for example, may hawak ka nga bottle or can of drink. Okay, depende sa imuhang bet. Basta kay wala pa nimo giabrihan, wala pa ka nag-abri og soda drink in a bottle or in a can baka ha. So closed system pa. Okay, take note ha, closed pa yung system. Now in that case, pag closed pa yung system ng bottle ng soda drinks or can ng soda drinks, at that state po sobrang taas yung pressure. Kasi nga gi-compress, di ba? Gi-compress ang gaseous molecules in that bottle or in that can. So, tataasan yung pressure para mas ma-dissolve ngayon yung mga content in that particular bottle. Now, ano ba yung content? Yung carbonic acid and, ako i-erase ha. Ano ba yung content na in equilibrium state in that closed system ng can soda drinks? Okay, so ito po yung content, yung carbonic acid. Ito yung carbonic acid. Okay? Kabalo naman mag-name, di ba? This is carbonic acid. Okay? So, ayan. H2CO3, carbonic acid. Okay? Now, again, in a closed system ng bottle of soda drinks, higher po yung pressure dyan. Okay? Para yung dissolved na carbonic acid is always equilibrium with carbon dioxide and water. So, equilibrium yung state dyan ng mga substances. Okay? So, mataas yung pressure dyan at, again, mataas yung pressure normally at closed system. Wala pa ni mo gi-open ha? Ayaw sa i-open. Okay? So, imagine na lang, wala pa ni mo gi-open. Now, Kanang sa ta mag-apply karon og stress? Sige, try nato mag-apply ngayon. Baliktarin natin from high pressure atong i-decrease ang pressure in that system. Unsaon nato pag-decrease, ma'am? I-open nimo. The moment nga i-open nimo yung can, bottle ng drinks, can ng soda drinks or bottle ng soda drinks, the moment na i-open na nimo, you are decreasing now the pressure in that system. Okay? So, na-open na nimo. Okay? Pag open nimo karon, ano yung mangyayari sa carbon dioxide? Di ba magbula-bula na? Magbula-bula, that is the evidence. That is the evidence nga maraming carbon dioxide ang naga-escape or being produced in the atmosphere. Okay? Lalabas. Kasi inopen mo, dinecrease mo yung pressure. Okay? So, hindi na, lalabas ngayon yung carbon dioxide. Hindi na ngayon equilibrium yung system. Di ba? Now, para ma-relieve mo, parang ganito, para ma-relieve mo yung stress, okay, yung direction ngayon ng reaction, papuntang reactant. Okay? Papuntang reactant. So, ibabalik mo, i-close mo ulit, close mo again, yung bottle or yung can. Okay? Then, ang mangyayari ngayon, yung direction is going backward para ma-relieve yung stress. Okay? Pero yun na nga, hindi na siya katulad ng dati. 'Di ba? Na sobrang at equilibrium yung state. Pero, at some point, magkakaroon ng backward direction yan para ma-relieve niya, ma-restore niya yung chemical equilibrium state. Okay? So, yan yung sa pressure. So, third na yun na factor affecting chemical equilibrium. Okay. Yung dalawang factor, okay, last slide na tayo. Okay? You have the catalyst. Pag nakarinig kayo ng catalyst, okay, sa any references, may it be chemical, chemistry, or sa ano pang related na mga topic in science, basta mayroon kag catalyst, okay, that is a substances, compounds, okay, substances used to speed up reaction. Okay, yan yung catalyst. Okay? Again, pag sinabing catalyst, it could be any substances that speeds up reaction. Now, i-relate natin ngayon sa chemical equilibrium. Di ba yung chemical equilibrium, meron siyang pa-forward at backward reaction, wherein yung rate of forward and rate of backward reaction equal. Okay? Now, pag sinabing catalyst, how can it affect the chemical equilibrium? Take note, si catalyst po, sabi it speeds up the chemical reaction, specifically the forward chemical reaction. Therefore, take note, yung catalyst, it only affects the forward reaction. It has nothing to do with the backward reaction. Kasi nga, it only speeds up the forward reaction rate. Okay, so yung apektado ngayon with the use of catalyst, yung forward reaction. Mas mapapadali ngayon yung forward reaction. Okay? And take note, catalyst, unlike other factors na na-discuss natin, it is never consumed. Okay, never consumed in a reaction. Okay? Hindi mo pwedeng sabihin na you increase, you decrease the catalyst. So, hindi siya nako-consume in the reaction. Okay? So, ayan. So, ano yung example ng mga catalyst? Example ng catalyst that speeds up chemical reaction. Sige, example tayo ha. Example, dali ko na lang ilagay. Example, yung mga metal catalyst like platinum, nickel, palladium. Okay? Palladium. These are metal catalysts. Strong metal catalyst. Another catalyst is Lindlar's. Lindlar's catalyst. Okay? And yung last factor affecting chemical equilibrium is yung order of reaction. Pag sinabing order of reaction, this is simply the relationship. Take note ha, ito lang po yung relationship ng rate of reaction, kung unsa kapaspason ang reaction with that of the concentration. So relationship siya between the reaction rate and the concentration of a particular reactant. Okay? So it still boils down. Pag sinabing order of reaction, it still boils down with the concentration of the reactants. Okay? So connected lang siya dun sa concentration. Again ha, itong order of reaction, it only relates to the rate of chemical reaction on the concentration of the reactant. So basically, it can only be determined experimentally. So mas madadiscuss po to more detailed as you go on your higher year in pharmacy. Kasi you cannot determine the order of reaction if hindi mo siya gagawin experimentally. Okay? So ayan. But again, related lang siya sa concentration ng reactants. Okay? Wherein, ganito yan. Wherein, pag nag-increase ka ng concentration ng reactants, okay, usually, in general, yung rate of reaction, ang kapaspason sa reaction, mag-i-increase din. Mas faster yung rate of reaction. Rate lang yan, rate. Rate of reaction. So, ayan, yan yung relationship nila. When you increase the concentration ng reactant, increase din yung rate of reaction. So that is in general. Okay, in general.